In this video, we will be using a pH meter to determine the strength of various acids. The difference between a weak and a strong acid is that a weak acid will only partially dissociate in water and a strong acid will completely dissociate. Because weak acids do not fully dissociate, they reach a state of equilibrium in which the forward and reverse rates are equal. Adding either more of a weak base or its dissociated anion will shift the equilibrium. Before beginning the procedure, you must calibrate the pH meter. In this video, Sam washed the pH meter with deionized water and stuck it in the pH 7 buffer. On the meter, he's typing in 7.0 and hitting OK. After the pH meter has been calibrated with the pH 7 buffer, wash the pH meter with deionized water and put it in the 4.0 buffer. Then type in 4.0 into the pH meter and hit OK. Now Mark will demonstrate calibrating the pH meter as well. He first rinses off the pH meter with deionized water, places it in the 7.0 green buffer, and types in 7.0 onto the pH meter. After placing the pH meter in the 7.0 buffer, the meter should read out 7.0. Then rinse the pH meter with the deionized water and type in 4.0. After placing the pH meter in the 4.0 buffer, the pH meter should read out a number close to 4.0. Then you rinse the pH meter, and here Mark is testing the pH of acetic acid. Acetic acid has a pH of about 2.57, so it is a weak acid. He just rinses off the pH meter and stores it back in its solution. Now Whitney will demonstrate calibrating the pH meter. She first rinses off the pH meter with deionized water and sticks it in the pH 7 buffer. On the pH meter, she types in 7.0 and hits OK. After swirling it around the green solution, the pH meter should show a number around 7.0. She then rinsed off the pH meter. After that, she sticks the pH meter in the 4.0 buffer and types in 4.0 onto the pH meter. This should read out a number close to 4.0. She then rinses the pH meter and gets ready to test tap water. So again, she rinsed the pH meter off and stuck it in tap water and found that it had a pH reading of about 5.17. This is an odd readout for tap water, but there may have been some experimental error. Now I will demonstrate how to calibrate a pH meter. First, I rinsed off the pH meter with deionized water and stuck it in the 7.0 pH buffer. I typed in 7.0. Once that's been calibrated, you rinse off the pH meter and stick it in the next pH buffer, which is the pH buffer of 4. I typed in 4.0 on the meter and waited until the readout matched up. I then rinsed the pH meter once again and got ready to test hydrochloric acid. So I rinsed the pH meter and stuck it in the hydrochloric acid and determined that it had a pH of around 0.67. I wrote down this data in my data table and rinsed off my pH meter. After the procedure is done and the meter has been rinsed off, you store the pH meter back in its solution. In this lab, we use buffers to calibrate our pH meter. A buffer solution is an aqueous solution consisting of a weak acid or base and its conjugate. These do not neutralize each other, but rather work to keep the pH of a solution relatively stable. When hydrogen ions are added to a buffer, they will be neutralized by the base in the buffer. Hydroxide ions will be neutralized by the acid in the buffer. As a result, the pH will not change very much.